Hi everyone, continuing the streams tutorial using Java 17. Today, what we're going to do is cover more in detail the basic concepts, the constraints, the fundamentals of stream in Java. All right, just a brief recap. Streams are nothing, but they have a source. They operate on data, perform some operations, and then have a terminal operations, which will give the result, which will terminate the stream. Okay. The operations are divided into two: intermediate operations and terminal operations. And together they are called stream pipelines. So a stream pipeline consists of a source. It could be anything. Last time in the last video, we discussed the different sources, the different ways in which we can create a stream. It could be array, generator, collection, or anything, followed by 0 or more. Again, see, importance is 0 or more intermediate operations and a terminal operation. Okay, such as map, collect, for each, reduce, which we'll be seeing later. Intermediate operations always return a new stream. Okay, so for example, if we had a filter, the filter will get the data, filter out the elements which matches the condition, and it will create a new stream with the data which matches the condition, whatever is specified in the filter. Traversal of the stream pipeline does not begin until the terminal operation is invoked or it is executed. So all these are not executed until it reaches the end of the stream or the terminal operations of the stream. After the terminal operation is performed, the stream pipeline is considered as consumed and can no longer be used. So if you want to do some other set of operations on the same source, you will have to create a new stream. Okay. You must return to the data and generate a new stream, start from scratch. Now let's go ahead and dive into more concepts. Parallelism, which means you can process the elements of the stream from the source in a parallel way. Boost the performance time. It is faster because you are executing or working on the elements in parallel. So if you're processing elements with for loop, it's inherently serial, like serial processing, one after the other. Okay. Streams have very good advantage of parallel execution, okay, which we can take advantage of. And then it works very well for aggregate operations, like summing and count. It works very well with aggregations. All stream operations can either be executed in serial or in parallel way. So say, for example, a widgets is a collection, okay, of the class widget. So it would be defined something like this. For example, it's a list of, if assume there is a class called widget, is equal to new array list. Okay, here, and then you have, you can create a parallel stream, filter out all the red ones. So only this section, when the elements which come here will be only the red ones. Assuming the class widget has two methods, get color and get weight, defined in it. And then what are you doing? Mapping it to an int it flattens this flattens the stream. What it will do is basically extract the weight out of this widget class and pass it to the sump, which will keep on adding. And once the stream is consumed, sum of weights will be the sum of all the widgets which are red in color, because we are filtering out only those which match the conditions. So here, whichever elements come here from the source are the ones which matches this condition. When this condition is true for them, go here. So that is parallelism. So imagine the time that we are saving when we have thousands and thousands of widgets and we can process it in parallel rather than processing them in sequence, right? So this is another very important concept. Moving on to another assumption is called non-interference. So streams enable you to execute, possibly parallelly execute, operations over a variety of data sources, including even non-thread safe collections such as ArrayList. So you can process elements sequentially or parallelly, even non-thread collection sources such as ArrayList. And this is possible only if we can prevent the interference with the data source during the execution of a stream pipeline. What does it mean is that while we are working on that data, which is coming from the source, it's an assumption that the source or the data inside the source is not modified, which means we are not assuming it's an array list or from somewhere it is, there is a source. So assumption is the array list is there are no new elements added or no elements are removed from the list. So there is non-interference of the source of the stream while we are processing the data inside the stream. Okay. So for most data sources, preventing interference means ensuring that the data is not modified. The data is not modified at all during the execution of the stream pipeline. There is an exception to that, which is a concurrent collections, which are inherently designed to handle concurrent modifications. So there is an example here. Let's say we created a list of 1 and 2. We created a stream out of this l.stream. We invoked the stream method, so to get the stream, and then we added it and the source, right? And then S1, what we are doing is just joining all the strings with a space. So see here, first a list is created containing of 2 strings, 1 and 2. Then a stream is created from that list. Next, the list is modified by adding a 3rd element. And then finally, the elements of the streams are collected and joined together so it will be a space separated string. Since the list was modified before the terminal operation commenced, the result will contain 1, 2, and 3. So that's another proof that it's a lazy, nothing is invoked here, right? It's just a stream. The stream, the filter methods or intermediate operations are lazy. They will only be invoked only after the terminal operations is executed. See, all streams return from JDK collections, and most of the JDK classes are well behaved in this manner. Side effects. Side effects in behavioral programming, behavior parameters to stream operations are in general discouraged. They can often lead to unwitting violations of the statelessness requirement, okay, and other thread safety hazards. What it simply means is that when you're processing avoid having side effect. Say, for example, if you create a stream from an array list, and in the results, what you're doing is for each S results.add, you're adding it to the final one. So this could be very neatly written as stream.filter, something that matches pattern, and then dot collect method, but this is collectors.toList, right? So you're not modifying, you're not referencing the endpoint. It's just this one will collect everything into the list and assign it here. That's avoiding unnecessary side effects. Another concept, ordering. As we said, streams, the intermediate operations, the order is not guaranteed, may or may not have a defined encounter order. Encounter means the way in which the intermediate operations are executed. So whether or not a stream has an encounter order depends on the source and the intermediate operations. Certain sources, such as a list or arrays, are ordered internally already, whereas others, such as hash set, they are not ordered. So some intermediate operations, such as sorted, it forces, right, to encounter order to an otherwise unordered streams. So if you have a sorted, like as one of the intermediate operations, then the processor, the stream processor, has to go process each element in order. Otherwise, there is no way that it can sort, right? What are reduction operations? Reduction operations, they're also called as fold operations. They are also the terminal operations. They take in a sequence of input, combine them into single summary result. There are different ways, like you can use reduce, you can use collect. For mathematical or integer or numeric streams, there is sum, max, count, average. There are tons of reduction operations. See here an example. So if you want to get a stream, so from number stream, you reduce. Starting element is 0, starting value is 0. And what you do? Just invoke the integer dot sum. And numbers is any list containing just digits or integers. And they can also safely run in parallel with no modifications. So same thing, processed as a parallel stream. This is a sequential stream. This is a parallel stream. So same numbers, same collections. If you have to get the sum, again, starting value is 0. And then with the rest of the elements, what you do, you keep applying the sum function. So it will internally create a variable aggregator, which will keep on adding the values to it. And then finally, when the stream is processed completely, the sum value is assigned to this variable. Reduction parallelizes well because the implementation can operate on subsets of data in parallel. Like it will take internally, it will take, say, let's say if there are 100 elements, internally it can take 25, 25, 25, 4, get the sum of all the sets of 4, 25 numbers, and then add them together, get the total of all the 100 numbers. So let's say if there were each 25, sum of each of the 25 numbers, these are called as intermediate results. And when you add the sum of all those 25 integers, you get the total of all the 100 numbers. So here, see, if we want to find the heaviest widget could be anything, any object, right? And let's say it has get weight method. So you're getting a parallel stream. So tons of widgets. You invoke the map to int. So what it does is nothing. From the object, call the getWeight method and pass that value, what the getWeight method returns, to the max object. And internally it will operate, keep a track of whatever is the maximum value. And once the entire stream is done, it will assign a value to this one. Here is another example here. So just a transaction stream. It is, say we have about 10 transactions. So we are filtering out only those transactions which has type of groceries. It will filter out. So let's say, for example, ID 3, 6, and 10, they are of grocery type transactions. These could be some other type. It will be filtered. So only those which matches the condition will come here. It will sort them based on the value, the one with the highest value, see, reversed. And see, there is a direction method reversed, which means descending order. The highest one is first, then this, and then this. Then your map, you get the transaction ID, and then you collect it to the list. So list contains transaction IDs, which are the highest value. Okay, so list of integers. So transaction ID 6, 3, and 10. It's just IDs, not the entire transaction object. See, because this is a list of integer. So that is it. Let's recap one more time what we learned about streams today. In the next lecture, we'll go in detail and see some of the stream operations in code, actually executing some code. Okay. Recap, operations divided into two types, intermediate and terminal. Intermediate are lazy. Terminal, they are invoked only when the terminal operation is invoked. We can have parallel streams, which helps improve the performance, reduce the execution time, especially when we have large data sets. It does that. Non-interference property concept, it's an assumption that after the stream is created or the terminal operation is invoked, the source should not be modified. The source of the stream should not be modified. Now here in this example, what we saw, it was okay because the collect was called afterwards, after the stream was created. But since collect is the terminal operations and the previous ones, there are no other operations, the collect is fine. It took into consideration the latest addition to the array list. Side effects, you should avoid having side effects. You can write a code without having any side effects. Ordering, in general, there is no order unless one of the intermediate operations or the source itself enforces ordering. So that's ordering fundamental. Reductions, they are actually called as fold. They are terminal operations. They are also called reduce, collect, sum, max, min, count. There are various reduction operations. What it does is, after the data is massaged, after the data is processed, the final result, whatever you ask for, is computed. And they are the terminal operations. So this is all the concept of string. And now we are once we are done with the concepts, once we are clear with the concepts, in the next lecture, we'll see streams in actions. We'll see different intermediate operations and different terminal operations, how they work and what results they produce. All right. See you all in the next lecture. Take care. Bye.